Hello. Today we're going to be talking about factoring special products. And right away you can look at these four problems and see that something is a little different than what we're used to. We have binomials here that we're going to factor instead of our typical trinomial or even four-term polynomial that we've been looking at. So the first one we have x squared minus 25. And what I want to point out to you is that we do have, in a way we have a middle term. Like if I were to say x squared plus 0x's minus 25. This is kind of what we're looking at. We still need a number that's going to multiply to make negative 25 and add. We have nothing in the middle as far as x to the firsts go, so we're going to add to 0. So we just make a list of things that do that. So things that multiply to 25 are 1 and 25, and 5 and 5, and knowing that we have a negative 25, we need 1 to be plus and 1 to be minus. So here we are, 5 and 5. Well, rather it's going to be 5 and negative 5. So we're going to have x plus 5 and x minus 5 is how that factors. All right, let's look at the next one. X squared minus 49. We have to multiply to make negative 49. And again, my middle term is 0, and that's what we're going to add to. So we make a list. We have 1 and 49, or 7 and 7, but again, because it's negative, it's got to be plus or minus. So here we are, 7 and negative 7. So we'll have x plus 7 times x minus 7. So perhaps you've realized the pattern now that when we get to the third problem, when we want to factor 100x squared minus 81, we don't have to list all of our factors of things that multiply to negative 8,100 and add to 0. Well, anyway, the numbers that are going to work are the ones that are going to add, are going to be the exact same, except one's plus and one's minus. So we're going to want 90 and negative 90. That's the option. So my outers and inners are going to make that. But if we factor this, for my outers and inners to be the same, we might as well take the same number. For instance, 100x squared is the same as 10x times 10x. And 81 is the same as 9 times 9. But we need them to be opposite signs, so one has to be plus and one has to be minus. Now in the fourth one, we need numbers that are going to multiply to 16 and add to 0. Well, things that multiply to 16, 1 and 16, 2 and 8, 4 and 4. But they have to add to 0. That means with the same sign, one of these has to add to 0. Well, these, at best, we could make 8, or we could make negative 8 if they were both negative. Okay, here we could do 10, or if they're both negative, negative 10, and so on. Here I could get 17 or negative 17. So none of these are going to work. So since none of them work, this one is prime. And what's the difference? What's the difference between this one and the other one? Well, it's that sign right there. Because of the plus sign, we can't factor this binomial. It can only be factored when if it were got a subtraction in there. So that's why we need a subtraction sign. That's why these are called a difference of squares. Difference of squares. It requires a negative sign in between my binomial and